And it's recording. All right, here we go. Let's go through our notes. So far in chapter 3, you've been learning about, or revising really, index laws. There are 8 of them. The first 3 is the most common one to do, or at least the one I always use. I avoid doing number 7 where I can. Okay, but when you start doing your solving and simplifying, don't ever leave, and just remind yourself, don't ever leave your answers, with a negative power. You will get penalized as you get to senior level. Okay, year 9, mainstream, normally we don't because we're trying to teach them the rules, but we do not accept negative powers. So if you left an answer, say 3a negative 2b, instead of writing it as 3b over a squared, you'll lose a mark. Okay, so I'm going to treat you exactly like how I normally mark my seniors. So make sure if I see a negative power, especially for a test, you leave a negative power, I will cross that off. That is equivalent to you leaving your answers as 2/4, okay, or 2/4. The best answer is half. If you don't simplify it, you lose a mark as well. Okay, so don't ever leave that. That's the only time you would use rule number 7. So that's just a reminder. I only use rule number 7 when I need to change negative powers to become positive powers. Otherwise, most times I'm doing 1, 2, and 3. But number 8 has specific times when you use them. Number 8 is when you start working with a lot of surds. Chapter 4 is going to be on surds. So let's remind ourselves, what was index law number 8? Hands up. Emma. Good.
It's got the n, root n. I know how to draw. I know.
Yeah, it's called the nth root.
Yeah.
Nth root is equal to. Shh. Thank you. Don't speak while someone else is speaking. I find it highly disrespectful.
Equal to a to the power of m over n.
Very good. So this is the rule that most students tend to forget, even all the way up to year 12. I was testing them just last session, actually, because we're now onto exponentials and logs, and they're almost finishing it by the end of this week. That's how fast we go at year 12. We go through pretty much chapter by chapter almost each week, or a week and a half. So they're up to chapter 6 by the end of this week. So that means by the end of this week, they've done 6 chapters, which by comparison, you guys are doing what? Chapter 1, and now you're doing chapter 3. So that's the speed that you travel at the senior level, only because all of this should be mastered. So this is revision, right? So I still revise this with them, and I still catch students who still not know this rule. So keep in mind, 1, 2, 3 is the one that you most likely use, and then rule number 8 is the one that students tend to forget, which is the ones that examiners know. Examiners know that students in Victoria struggle with fractions, negatives, and surds. It's been like that ever since I started high school as well. It's just one of those things that students don't get really good at. And then if you practice your algebra and you're really good at it, then that's advantage to you. So here's a reminder. With that rule number 8, square root of a is the same thing as writing what? Now I mentioned in my last session, is equal to what? A to the power of, yes, Michelle? It is a half. Okay, so this is already called a square root. That's why we don't put the 2 in front of it, because we know it's a square. But then anything that's not a square root, that's why we then put the number. So like cube root, 4th root, 5th root, all of those we need to put a number. But by the pattern, all of them have a to the power of 1. So the 5th root, or the 3rd root, or 4th root should be a to the power of what? What's cube root? Mira. Put the screen. Say it again. 1 over 3 is correct. Next one, 4th root, Jaden. A to the power of 1 on 4. And then 5th root, obviously, Sean. A to the power of 1 over 5. Okay, now these are very useful to understand, especially when you're starting doing surds and you're trying to simplify a problem. Now, on the side I wrote remember. I wrote remember because we know that the inverse of squaring, or the opposite of squaring, is square root. Just like the opposite of adding is subtracting, and the opposite of times is divide. Well, then the opposite of square and square root, the reason why they both cancel and why this rule has to be true is because a to the power of what? See, we don't know what the power is. If it has to end up being a to the power of 1, because they're meant to cancel out, right? So you're meant to be a to the 1. Then rule number 3 states what? What do you say about the 2 in rule number 3? What can you do? You times them. So this question mark, you can kind of think of it as a to the power of something times 2 has to equal to 1. What would that something have to be? 1 over 2. Very good. And that's where we then have that property that if root of a is equal to a to 1 on 2, then the square root must relate to the fact that it is the denominator, power of the denominator, which is really interesting. So at a year 12 level, this is what I was testing the students. I said to them, because I got up to this step, we were doing this algebra solving a problem, and we got up to this step where it was, I think it was x to the power of negative 5 on 3 is equal to, I'm going to make it simpler for you guys, but it was something else. It was a fractional one, but let's just say it's 7, right? The question was, how do you get x? And this is where it stumped the year 12s. They all sat there and they're like, I don't know. And I said, well, this actually goes back to your rule number 8 in indices. And I asked them, do you remember rule number 8? And they're like, no. So then I wrote out exactly the way I did it for you. I said, this is equal to what? And most of them don't remember it. But let's have a look at this one. If we were to solve that, using what you just realized here, something squared, to get rid of that to make it 1, because our goal is to find x. So it means our goal is to get x to the power of 1 is equal to something. What can I do to the left-hand side to make it equal to 1?
Would it be x to the power of negative 5 equals cube 7 and 3 square root of 7?
We'll say that again. So x to the power of negative 5. So x to the power of negative 5.
Square root of 3.
So cube root of 7. No, not yet. I thought you were onto something, but not that. No, this would be algebraically incorrect. Because we got to get rid of that cubed, or that denominator. Now look at the two patterns. What if I write the half here, maybe you can see it. Do you see anything familiar? Think about it. Cube root. What's the opposite of cubing? So if I got cubed, cube root, not square. Okay. Opposite of cubing is cube rooting. Now the reason why this works as well, same idea. If I asked you to do the cube root of cubing, it's a cubed to the power of a third. Do you see that? Because cube root is power of a third. That's a3, right? So these two will cancel out. Why? Rule number 3 says if you did 3 times 1/3, that will cancel out to be 1. If I asked you 4th root of a to the power of 4, this is the same thing as saying a to the power of 4 all to the power of a quarter, because Jaden told me before that the 4th root is power of a quarter. Why do they cancel out? Rule number 3, 4 times a quarter is 1, so it does cancel out. Are you seeing a pattern? What's the pattern? Beautiful. Exactly what I said to my 12s. You don't have to always do a square and square root, cube and cube root. It could be negative to the power of negative 513. But the reality is that if you wanted a 1, as long as you times by the reciprocal, because 1/4 is a reciprocal of 4 over 1. 1/3 is a reciprocal of 3 over 1. So then what would I have to do to both sides to make sure they both cancel out? Well, the logic is, if it's negative 5 on 3, if I just said on the left-hand side, I say to the power of 3 on 5, negative, then by multiplying those two together using rule number 3, 3 and the 3 will cancel out, 5 and the 5 will cancel out, and double negatives will be positive, ends up being 1. But whatever you do to one side, you have to do to the other. So the answer would have been to the power of negative 3/5 on this side, which Andrew was pretty close, except she did the 3rd root, which is 1/3. But instead of third, it should have been cubing, because it's opposite of cube rooting. Yeah? So the answer would have been 7 to the power of negative 3 and 5. But knowing at year 12, you can't leave your answers negative power, so what should the answer truly be? Think about it. Which rule is this one now? 7 to the power of negative 3/5 is the same as? 3 on 5. Yeah. So the power in itself, remember that rule number 7 was a to the power of negative m is 1 on am, right? Doesn't matter what m is. M could be a fraction. So when you bring it down, it should still be a positive fraction. But you could write it the way that you were about to say it. You were about to say 1 over the 5th root of 7 cubed. And that's fine too. Okay, so either answer would have been accepted. I usually keep it in this answer because that means you can move on and do more algebraic stuff. Once you turn it into a surd, it's hard to play around with surds. Surds are much more rigid compared to indices. Okay, but that was an example of a year 12 question where I used your basic year 8, year 9 rules and then moving on to year 12, how you can then solve problems like that. Make sense? But today's lesson obviously is not going to be that tricky. It's going to be much easier. So let's have a look at this one. Example 1. Example 1. So all you're asked here is to change all of these into index forms. Because remember, surds is limited. There's a lot of restrictions in surds. So we do like indices. Gives you a bit more freedom. So here, root of 11, that's a square root. So to write square root of 11 as a power or as an index form, it should be what? Can I please have, let's go Raphael.
11 to the power of 1 over 2.
Very good. Okay, so knowing that the square root symbol is the same thing as a power of a half. So if you didn't have a square root symbol on your calculator, you can actually type 11 to the power of half, and that means square root of 11. Okay? Let's try the next one. So the first one's pretty easy. Next one is 2 times, now this is the 4th root of x to the power of 9. Now, x to the power of 9 is here. Now we need to rewrite the 4th root. So the 4th root is the same thing as writing the power of what? Let's go with Samuel. Power of 1 on 4. That's it. So you see how I changed that 4th root? Instead of the square root, now it's the 4th root of x to the power of 9. So 4th root we know is the power of a quarter. And then looking at this, that is rule number 3. Index law number 3, what do we do with the powers, Olivia? You times them. So it becomes x to the power of 9 times a quarter. And what is 9 times a quarter? Let's go with Sunny. 9 quarters. You can leave your answer like that. Okay? No negative powers, but positive powers fine. If it's fractional, that's okay as well. Nothing wrong with fractional powers. Okay, so that would be a 2 times x to the power of 9 on 4. Pretty straightforward. That's rule number 8. This is the benefit of being able to change it. You can then simplify things as well. Let's try the next one. Turn over the next page. All right. So these questions now is about you expressing and evaluating. Let's try this one. Let's go with A. Example 2A. Express the following in surd form. So this is different. This time, instead of indices, sometimes you do want an answer in surd form because maybe all the other questions are in surds. Then you can simplify using surds. So 11 to the power of 2/3 using your index law number 8. So think backwards now. What should the answer be? Let's go with Toby. What do you think the answer should be?
Two times the cube root of 11.
2 times the cube root of 11. Like that?
Yeah.
So close. Just missing something. He's got the 3rd root correct. That 3 means the 3rd root, so he's got that bit correct. Where's the error, Violet? Beautiful. So remember, this, I'll just write the rule again so you can see. It's the nth root, so no matter what that cube root is or nth root, to the power of a to the power of m. So a is always the base, it's the number. And that's equal to a to the power of m on n. So whatever the power is for the base, that goes on the top. The nth root goes in the denominator. So you can see here, the denominator is 3, so he was correct. Toby was right to say it's 3rd root. But remember, this is a square. That 2 belongs to the base of 11. So that should be right here rather than the outside. Okay, so not the 2 on the outside, but it should have been cube root of 11 squared. Okay, so that's working backwards now. We're going from this to that rather than this to that. Sorry, from this to that. indices to surds. Let's try the next one. And that's all you got to do. That's your surd form. Cube root of 11 squared, which if you wanted, you could write cube root of 121. Okay? Because 11 squared is 121. All right, let's try this one. Evaluate the following without a calculator. 64 to the power of 2/3. You can change that into surds or using your indices. Now let's think about it. Notice that this is the power of a third. One of the trick is that denominator, you can cancel it out if the inside was a cube, because the reciprocal of the denominator 3 is 3 times a third, right? So is there any way that I can write 64? Can I write 64 as something cubed? Because that would help. What would that be? You said squared?
Yeah, I thought squared.
Oh, you could do squared as well. It just takes a bit longer to get down. 4 cubed. Now, if you didn't know it was 4 cubed, it's okay. You could have done with 2's, and it still breaks it down slowly, though. It's like finding your highest common factor kind of way. So here, 64, if you didn't know it was 4 cubed, you could do it this way. You do 64, break it up into 8 times 8. 8 is 4 and 2, and this is 4 and 2, and then you have an option here. You have an option of breaking the 4 further into 2 times 2, but that would be then 2 times 2 times 2 times 2 times 2 times 2. That's 2 to the power 6. That works. Nothing wrong. Yeah? Or you could have noticed that 2 times 2 is 4. 4 times 4 times another 4 is 4 cubed. So it's up to you. Yeah, so it could have been 2 to the power 6, or it could have been 4 cubed. Either way, you would have got your answer correct. Nothing wrong. Yeah? So I'm just going to stick with cubes because this is usually a hint to what you want to work towards. So when I see that denominator 3, I think of, can I cube something to get there? And we do know that the cube of 4, actually I'll take the brackets away to help you not get too confused. 4 cubed. 4 cubed is 64. It's all to the power of 2/3. Rule number 3. We know that rule number 3 means that you can multiply these two powers together. It's 4 to the power of 3 times 2/3, but nicely, 3 1/3 is meant to cancel out the way I was hoping. So you actually end up with 4 squared. And that gives you 16. Okay, but if you did it 2 to the power of 6, it still would have worked as well. 2 to the power of 6, 6 times 2/3 would have gave you 2 times 2, I think it is, and it's 4, so 2 to the power of 4 is 16 as well. Okay, so it still works. All right, last question. Last 2 questions, same idea. So using the same one rule to help you evaluate these. I'm going to pause the video. I'm going to give you 5 minutes to do both of these two. Okay, here we go. I'm going to pause the video. I want you to have a go. Here we go. 5 squared, and then 2 times -3 on 2, 5 to the power of -3, hands up if you got the first one correct. All right, I'll see where you're at. So get the first step. Did you get the first step that 5 squared would be the best option? Okay, good. So that's first step. Second step is multiply them. 2's cancel out. Never leave your answer in negative powers. Use rule number 7. And then this says evaluate. So 5 cubed. 5 times 5 times 5 is 125. Okay, so the very first step is key. Next one. B. Your first step or key step should be to change that 100 to something squared, because that's a denominator of 2 there. So it should be 10 squared. Hands up if you got 10 squared. 10 squared. Good. Bit worried for some of you. That's okay. If you got 10 squared, then using rule number 3, you should have got 10 to the power of 2 times 3 on 2, and the 2's should cancel out. Then it ends up being 10 over 10 cubed. But then 10 cubed just means 1,000. So dividing that should give you 1 on 100. Hands up, you got that all correct. Good. That's it for today's lesson.